Alrighty, so welcome to CSIS 42, Programming with Python. I'm Alex Stoikov. I'll be teaching this class for the summer and hopefully after that too. This is your class homepage. So if you go to the courses and you go to CSIS 42, that should land you right into this webpage. I have disabled all these other things on the left, so the only thing you should see is the home and grades. Okay? And I already sent this little welcome message to everyone yesterday, right? Just in case you haven't read it. The general thing is, it doesn't matter in what class section you're registered in. I really don't care about attendance. As long as you turn in the assignments, I'm happy, and that's how I measure your attendance. Okay? So, doesn't matter if you're in the face-to-face section or the online section. You don't have to switch. Okay, if you need to miss a class, you can miss a class and finish the work from home. There's no textbook. Everything that you need is already on the class webpage. And yeah, you're not going to need a textbook. Everything you need is on the webpage. So, best way to contact me, send me an email, put the CSIS 42 in the subject line, and you can also send me a message on this system here. That works well. And if you're going to be sending me an email, put the CSIS 42 in the subject. Otherwise, if you're going to be messaging me here, it lets me know automatically. Okay, so you can read through the syllabus. There is no textbook. I mean, there might be a textbook on the syllabus, but it's just because I need to have a textbook on the syllabus. But that's not the textbook I'm going to use. I'm not even going to look at it. Okay, in fact, the reason I don't have a textbook is because I haven't found a good one. If there was a good Python textbook, it would be very easy for me to tell you, read chapter 1 and do these assignments, but I had to write the whole thing myself pretty much. There on the top of the web page, there's the welcome message, there's the syllabus, so read through these. And there's some extra resources. And if you open that thing, you're going to see there's some extra Python resources. There's a couple of free textbooks that you can read. If you want to get confused by them, go ahead. But there's no promises these are going to help you any extra. There's some online classes that will teach you Python, some more advanced than others. Berkeley has a data structures with Python online. That's probably the hardest one. Udacity has some certifications with Python that you can do. Okay, but I'm not even going to look at any of these. CodingBat is something we're going to use, and yeah, I'll leave it at that for now. So, this is a 4-unit class, meets from 11 a.m. to 12:50, and it's broken down into 6 weeks. If you click on week 1, you're going to see a few how-to links in there. So, if you want to know how to install Python or where to get Python and how to write a program and all that good stuff, you can go through these, but I'm going to make a video of all this today so you can watch the video this video. Okay, so first of all, where do you get Python? Well, you go to let's go here. So let's go to just Google Python, right? If you just Google Python, there's python.org. Just click on the download link, right? You don't have to do that on these computers here, but if you have a laptop, if you want to work on your computer at home, that's one thing you can do. There's direct links here for Python 3 and Python 2. We're going to be using version 3. Any version 3 that you want to get is fine as long as you can install it on your computer and works. I personally prefer, and I'm using this one right here, Python 3.4.4. And the reason for that is because after version 3.4, all these 3.6, 3.5, they started installing themselves in some weird places. So up to that point, Python would put itself right on the C drive. It's very easy to find. And after that, in version 3.5 and above, it starts going like really, really deep into folders in your system. So if you don't want to try to find where that is, pick 3.44. And if you scroll down, you're going to see there are a couple of links for you to install this thing on a Windows or a Mac. Okay, so all the versions are in there. If one of these versions doesn't work for your computer, try maybe an older version or a newer version. Especially if you're on a Mac, you have to get a version that's compatible with your OS. Okay, so sometimes you might have to go with an older version, in case you wonder. Okay, so once you get this thing installed on your computer, and whether it's a Windows or Mac, you just type idle and open up idle, right? So idle is where we're going to write our programs, and that's a really big font size. So let me try to edit preferences. Let me make it a little smaller font size. Better. Okay, so this is the Python shell. This is where the programs are going to run. This is not where we're going to write our programs. Okay, a lot of the textbooks, which I don't like, show you how to write programs within this thing. I don't like that at all. So we're not going to write our programs here. This is where they're going to run. Where are we going to write our programs? Well, once this window is open, you're going to go File, New File. It's the same on Windows, same on Mac. You're going to go File, New File. And in this little window is where we're going to write our programs. Okay, so let me just begin by just writing some things like a print, hello, right? So in any programming language, the first thing you should be able to do is just get something out of the program. So this is how you do some output with Python. Okay, so if I just run this, so first I have to save it. If I try to run this, and by the way, the way you run it is, just go run and press F5. Okay, you have to save this thing first. Okay, I'm going to put it on the desktop. This is going to be lecture 06/20/2016. Okay, and when you run the program, it will show the results. It's output right in here in the shell. Okay, so things that you are supposed to have in your program are, so this is just the basic programming instruction, right? This thing tells the program to do something, right? So this is example of output. Okay, and output is information that goes out of the program. Okay, and if I run this program again, the way I have it, right? So before it showed you the little hello, right? And if I run it again, right, I'm just going to press the F5. You're going to see that it shows the same exact thing. In other words, this stuff in red had no effect on my previous program whatsoever. And that's what a comment is, right? So anything that starts with the pound sign is a comment, right? And comments are explanation, right, for your code. They're not considered programming instructions. I can run this program again, and you're going to see that all this stuff in red that I wrote has no effect. It just keeps showing you that little hello message. Okay? So, what comments are you supposed to have in your program? Well, that's part of your grade, so make sure you have this in all of them. All right, so the first thing is make sure you have your name, right? Alex, that's my name. And make sure you put the program number. Okay, so every program is going to have a program number. So if you go to the week 1 and look at these, you're going to notice that there's a P1, P2, P3, 4, 5, 6, right? So these are your program numbers, and that's what I want you to include. So let's say this is going to be P0.py. Other thing that I would like you to include in here is your version, right? And the version that I'm using is 3.44, okay? Date started, finished, right? If you had different dates when you started this and finished it, right? Today is 06/2016, right? Put that in there. Sorry, 17. And the other thing that I want you to include is description, right? What is the program supposed to do, right? Okay, and by the way, I will post these notes online, so don't worry if you can't type everything I'm typing. I'm your note taker, okay? Plus there'll be a video that explains what I typed. All right, so any questions about anything so far? Pretty basic? All right. So these are the comments that you're supposed to include on top of every program. So every program should have the following comments. Okay? So these lines right there. In addition to this, every program that you're going to submit needs to show me how you tested this program, how it works. And what we're going to use is we're going to use a multi-line comment. So we're going to use single quote, single quote, single quote, enter, single quote, single quote, single quote, and then I'm going to go into this shell window. I'm just going to copy the whole thing, and I'm going to paste it right in between these two. Okay, and if I run my program again, you're going to notice that nothing changed as far as running the program. It's exactly the same, but you know, I added some extra quotes on the bottom. Okay, so these are called multi-line comments, which means that you no longer have to go and put the pound sign in front of every line. You just start them with 3 single quotes and you end them with 3 single quotes, and anything in between is a comment. Okay, you could use these multi-line comments for your description. Okay, and in the description, you can just go and copy it from the assignment webpage. Okay, so that is the basic stuff. Any questions so far? All right, nothing hard yet. So let's have a look at some of the things that I have here under Tuesday. Okay, so I already told you about comments, right? What you should include in every assignment, right? Top of the program, you gotta have these comments. At the bottom of the program, you gotta show me how the program ran. The next thing I'm gonna do is give you some examples of output, right? So I already told you, output is an information that comes out of the program, and there's different ways for me to format my output, okay? And I have them listed right here on the bottom of this web page, and I will show them to you right now. So before I get into more fancy things with output, right, what I'm going to do is I'm going to quickly introduce a variable, right? Let's say my name. Okay, this is a variable, and I'm going to make it equal to Alex S. Okay, so this is the variable name, right? And this here is what that variable is equal to. So the variables are just words we make up to store information, and I'll get into detail about this in a second. I can show these variables using my print, just like I'm showing you here. So in here, I'm going to put a comment. So make a variable my name, set it equal to Alex S. Okay, and in here, what I'm going to do is I'm going to show you print my name equals my name. Okay, so this is an example of outputting a variable, right? Output of a variable. Okay, so if I run this thing, it shows you my name and then Alex S, right? So the first piece here is the little text that I put in quotes, and the second piece that I have in here is the actual value of the variable. Anything in quotes is called a string. Okay, so when I said my name is equal to Alex S, I'm actually saying that the variable my name is equal to a string Alex S. Okay, so this here, this first piece, this is an example of a string. Okay, and then the second piece right here is the actual variable that you're showing. If I change my variable here to, let's say, lowercase Alex, right, and I run the program again, you're going to see that the first piece right here stays the same. The second piece changes, right? That's what variables do, change their values, okay? And that's about it for now. So let me show you how to format your output. And the examples that I have, you can see, for example, let's go back to the web page, all the way at the bottom, okay? There's a couple of these. And let's say I have some numbers, right? So I'm going to copy this. Okay, I'm going to paste it in there, and I'm actually going to show you one way to do this first. So pi is equal to something, And you don't have to put variables, you can just put numbers like I'm putting right now. And then E is equal to something else. All right. So I'll show you several ways to do output. So E is equal to this. Okay. So let me get rid of this. Okay. And if I run this thing now, right, it shows you these here. Okay. So what I did is I put some label, I put a string just like I did on top, and then next to it I put some number, right? That's what it shows here. Then I put another string in here, and then I put some other number. Okay? That's one way to show, and by the way, I can do this. I can say, all right, pi is equal to this value here, and I can say E is equal to this value here, right? And instead of pi here, I'm just going to use, instead of this, I'm going to use pi. Instead of this, I'm going to use E. I'm going to run the program again. Should give you the same answer, same result. Okay? And that's just the basic way you show output with Python. Okay? That's the easiest one. But it's not always going to work. And sometimes you want to do things like, oh, maybe you want to format this to show only 2 decimal digits and not all 4. Or maybe you want to round this thing to 1 decimal digit. Okay? And that's the next one. So if I copy, I'm just going to go back to this. So I'm just going to copy this line here. And what I'm going to do is I am going to change it a little bit. So this one here is going to be %F. And this is also going to be a %F. I'm going to delete this comma. I'm going to make this a %. I'm going to delete this comma. I'm going to make this a %. I'm going to run it again so you can see the difference. So that's the second one. Okay, so the first one, the first print shows you these, and the second print shows you that. So it adds some extra zeros at the end. You probably don't want that. And that's okay because this is going to let you format it. So I'm going to go in there, I'm going to say, okay, this is going to %.2f, and this is going to be %.1f. Okay, what the .2f tells it, right? So %.2f tells it insert, right, means insert the variable pi, round it to 2 decimal digits. Okay, that's this one. And this should tell you that this one is insert the variable E, round it to 1 decimal digit. Okay, so if I run this again, now you're going to see that this thing is rounded. Okay? Now, what else can you do with this format? You can group all the variables together all the way at the end. And so let me grab this, paste this here. What I'm going to do is I'm going to take this variable out of here, and I'm going to put it right here, right? And I'm going to combine these 2 strings together into one big string, like that. Maybe put a comma in between. Okay? So the syntax or the rules of the language tell you that you have to get rid of all these extra percents and put commas in between the different variables, just like this. Okay? It's very similar to how C++ does things. Okay? So what does this mean? Well, we're going to insert a float, round it to 2 decimals. And what's a float? First of all, there's different data types, right? Different types of information are your data types, okay? So the different data types so far is, this one is a string, okay, variable name, and then Alex S is a string, okay? So that's one data type. Anything that's in quotes, that's called a string. So text, anything in quotes. I can go in there and throw in special characters, right? Whatever I want, no problem. What else? So string is anything in quotes. And these here, a number with decimals, right? A number with decimals is a float, Okay, so that's one data type. So both of these numbers here are floats. Pi is equal to a float, e is equal to a float. So in here I'm telling it insert a float or a decimal number rounded to 2 digits, rounded to 1 digit. Okay. You could also have integer variables. Okay, so let's go in there and say, okay, this is going to be integer variable, right? And what is an integer? Integer is a whole number. Okay, so let's call this age is equal to 3. Okay, that's an example of an integer. So let's say, for example, I wanted to go in there and insert an integer in this line right here. I'm just going to go, all right, I'm going to say little space age equals %i. That's for the integer. Which integer I'm supposed to go and put there? Well, I'm going to put the age. So comma age, right? And it just inserts them in order. The first thing here is going to be this. The second thing here is going to be this. And the third thing here is going to be my integer age. Okay? And if I run it, hopefully it works. And there it is. Okay? Any questions? All right. So, what else? So that's one example of how you can do output. Okay? So one is with the commas, one is with the percents, and you can also round the percents if you want. And there's another one, which is, I'm just going to grab this first one, and I'm going to put it under it. So this one, but now I'm going to change it to plus str, and then plus, right? And this one is also going to be a plus str, right? So what I'm doing here is I'm telling the program, turn this thing, which is actually a float or a decimal number, into a string, right? You already know a string is anything in quotes. So the effect of this whole thing is it's going to put all these 3 strings together into one big string. That's called string concatenation, and I'll revisit that in a second or later. Okay, so if I run this thing, that's the second one. I'll put a little asterisk in front of it. Actually, no, I'll just run it. Right, you're going to notice that the first one, right, the first one has like a little extra space right there, and it's because the comma introduces an extra space. The plus str format does not automatically put a space in there, okay? So if I wanted to, I have to go in there. If I wanted both of these first 2 lines to match exactly, I have to put a little space in there. I'm going to have to put a little extra space in there. Anytime, any place there was a comma, I'm going to have to put space inside of the quotes. Okay, and then if I run this thing, then both of these 2 lines are now identical. Okay, so these are the 3 ways for you to do output in Python for now. Okay, this is what we're going to be using when you write things to files, this one or this one. Okay, this one here is not going to work when you write things to files. Okay, so right, so I already showed you a little bit of the different data types. So we have integer, we have a float, and we have a string, right? And I introduced a couple of variables in there. So this was a variable right here, this was a variable right here, this is a variable right here. Okay, so what is a variable? Okay, let me put a little bit, put this under. Okay, so I'm going to put all right, let's just single line. So variable is just a name we make up to store information. Okay, there's only a few rules as far as making up variable names. Okay, so I'm going to put multi-line. So rules for variable names are, first one is can't start with a number. Okay, if I go in there and let's say this first one here, I just decided to put a number in there and I try to run my program, that's a problem. Okay, tells you invalid syntax because the rules of the language or the syntax do not allow you to do this kind of things. So just like the English language has its rules, you got to end a sentence with a period maybe, or something else, maybe start the sentence with an uppercase letter. Python has its own rules. Okay, and one of those rules is you can't put the number in front of the variable, okay, or you get a syntax error. You could put the number in the middle, you can put the number at the end, right, and there's not going to be a problem, except later on I'm getting now this error here. Okay, why am I getting this error? Because I changed the variable name here to something else, and then I'm trying to show the old name here, and it's telling me it's not defined. It's not defined because I didn't define it as this, I defined it as this. So I either have to change this one here, or I'm just going to change this one back to what it was. All right? And then the whole thing's going to work. Okay? So, other rules for variable names are you can't have spaces. Okay? So in here, I can't go and say space my name, right? If I try to run this, again, it's going to give you invalid syntax because now it thinks it's two separate things. Bottom line is you just can't have a space. Okay? You cannot have anything else other than underscore. Okay? You could connect separate words by just either capitalizing, right? So you can capitalize every subsequent letter of the first letter of every subsequent word, or you can just do the underscore and then make two words that way. Okay, both formats are widely used and totally okay. I use both. When I get sick and tired of using one way, I just go to the other. Okay, try to keep things consistent if possible. Okay, but I'm not going to force you one way or another. So the only thing that you're allowed to use to connect words is the underscore. Okay, and that leads me to the third rule. Right, the third rule is can't have any special characters or symbols. Right, so you already know that the pound has its own meaning. So it will make sense if I went in there and I said, "Oh, pound here," that'll mess things up for me, right? Because I just took out everything after that. Okay, so you can't use the pound, you can't use the exclamation. In fact, you can't use any other special character other than the underscore. Okay, that's the only one. Okay, so can't have any special character symbols other than underscore. Okay, and those are pretty much the fixed rules. Now the rules that you shouldn't do, right? That one is don't use reserved words. Okay, reserved words like print, that's the only one you've seen so far, or maybe str. Well, you could use str if you want, but definitely don't use print. Okay, so such as print. And why is that? Well, Python lets you define variables on the fly. In other languages, you have to tell it, oh, this is going to be a string, and then it's going to be, then you can do the same thing that you're doing in Python. Python automatically figures out, oh, this is going to be a string, so I'm going to make this a string. Okay, so it's very flexible in making up these variables, and it's so flexible that you can break the Python itself. So for example, in here I'm going to go, obviously you see the program is working fine under, but I'm going to go and I'm going to break it by just making up a variable name called print, and I'm going to make it equal to, I don't know, 1, 2, 3, 4. All right, and that's okay. This line itself is not an issue. The issue is that now I change the meaning of what print is, and the program after that is going to get broken, and it's not going to know what print is supposed to do. So if I run it, it'll give you this error. Okay, and object is not callable. The meaning of the error message is this used to be a function that you can call, and we'll get to functions when we get to them. But now I changed the meaning of that function to something else, so it no longer works. Okay, so that's why, that's this rule here, don't use reserved words. Okay, so if anything is turning purple, especially if you have print, don't rename the print to something else. And last but not least, use, just to make sure you're paying attention, so use meaningful variable names. Okay, it will be much easier for you to call the variable what it's supposed, name the variable based on the value that it's supposed to hold. So if it's going to hold the value for an age, call it age. If it's going to hold the value for pi, call it pi. Or e, call it e. Don't go in there and call it num1 and num2 and num3, right? And then later on you have thousands of lines of code and you're trying to remember what was num1. Call it what it is, right? Just give it meaningful names and then it'll save you trouble. Okay? So those are the rules for the variable names. Okay? And again, variables are just words we make up to store information. The different kinds of information could be integer, could be float, could be string. Okay? Any questions so far? Yes?
About the percent.
Yep.
Percent sign.
Uh-huh.
Print inside the parentheses. The percent sign that will return number, any number, decimal.
The percent itself,
whole number also.
the percent itself just tells it there's going to be something else, right? It's either %f, %.2f, any number here is fine, right? The whole number is the %i, right? So %i, right? %i tells or means insert the, so this one was insert the float variable pi. This one is insert the integer variable age. Okay?
The percent I could be percent any other.
No. There's the percent I can only be percent I. There's also a percent D actually, but I'll leave it like that. Same thing.
S, no.
There's a percent S. So if you want to know all the other ones, they're right here. Right? There's your percent F, there's a %.2f, there's a percent I, there's a percent S. There's another format right here, which lets you format some really big number with comma, right? With commas with 1,000 separators. So if you want to do something fancier, these are all the different formats. So look at this link right here on the week 1, and yeah, they're all in there with all examples. And you should, just the easiest thing to do is just copy this, paste it in your Python program, and then run it. See what it does. Okay, when in doubt, just do that. Okay, and yeah. So let me just show you this last one right here, this fancier format. I'm just going to copy it, right, just to show you. So if I wanted to, there's another way to do this, and that is with these curly brackets, right? So you have to do curly brackets, colon, this, and then I'm going to format this number into something. So if I run this, then it gets formatted like this, right? So I see the number as that, okay? And that's pretty much all the ways you can do it, okay? So %i, %f, oh, and there is a %s too, right? So if I wanted to show anything, actually I can show as a %s, right? I can go in there and I can show age as a %s. Because anything can be a string, I can show anything as a string, okay? But for now, just stick to the format that I'm showing you. So if it's a float, call it a float, %f. If it's an integer, call it a %i. Question?
Why do you need the pluses when you change it to string? Can you
This
delay
here?
the pluses, or is that for concatenation?
Yeah, well, it's for the concatenation. Yeah. So what I'm doing here is I'm adding different strings together, and I'm just going to show you. So this here, this whole thing. Well, actually no. So the plus signs, right? Yeah, when you have a plus between two strings, let's say, all right, the whole thing. Right? This is string concatenation. So let's say, for example, I have first is equal to Alex, right? And then I have second is equal to Stoikov, right? And I say both is equal to first plus second. What I'm doing is I'm adding two strings together. Adding two strings together is concatenation. Is concatenation. So if I go in there and I do print both equals both, and I run it, Where's the both? Both is right here. Okay, so what did it do? It got one string and put it right next to the other string and turned it into one big string. So that's what I'm doing here. I'm telling it, turn this number into a string, turn this thing also into a string, and then add them all together. Okay, yeah, that's about it for now. Okay, now let's have a look at the web page. What do I have next? Okay, so variables. I already showed you the different kinds of variables. Just to explain to you what's really happening is you have some kind of a variable name, like for example my name, and then you have some kind of information like Alex, which is a string that is stored in memory. Okay, there's lots of memory locations. Each of these memory locations are in RAM, your random access memory, right? And each of these is referred to some kind of a number, right? So just like when you go to a web page, when you go to google.com, you're actually going to some IP address like this, okay? But it's easier for you to remember google.com than it is for you to remember this number, plus this number can actually change. Okay, so the location, the exact location of where the variable is stored, this particular number can change, but who cares? As long as you remember what the name is, that's all you care about. Okay, and that's kind of the difference between a lower level and higher level languages. In the lower level languages like assembly, like C and C++, you have access to the memory. You can look at the memory addresses and you can move things around in memory. Python doesn't really do that kind of stuff. It's really abstract. It's on top of, you don't go in that level. Okay, but that's what really happens. And the different data types, I already showed them to you. The whole numbers, right? Those are the integers. These are some examples of whole numbers. The floats, those are the decimal numbers. These are some examples of decimal numbers, and these are some examples of strings. Just a quick thing about strings. As far as Python is concerned, there is no difference between double quotes or single quotes. So whether I put something in single quotes or double quotes, it still thinks it's a string. Okay? So this is different from other languages where the double quotes are reserved for strings and single quotes are reserved for characters, right? So, but Python does not have single characters. It's all strings. Okay. All right. So going back to the class webpage real quick, and okay. So Python language is dynamically typed, which means that the variables automatically figure out their own data types. Like I showed you, you don't have to go in there and tell it, oh, this is going to be a string, right? It's going to be a string called first, and that string is going to be equal to this. This would be the format how you do it in different languages. So if you did it in Java or C++ or a lot of other languages, you have to tell it what the type is in advance. Python does not do that, and that's what it means for it to be dynamic, right? So it's dynamically typed language. Okay? Python is a strongly typed language, okay? So that means that if I try to go in there, and let's say I'm going to remove these, I have the pi, right? I'm going to get rid of this. So I'm just going to leave it as pi, right? And I'm going to get rid of this here, right? And I'm going to run it again. Oops. Can't convert float object to string implicitly. Okay? So, that's what it means that it's a strongly typed language. Basically, it will not do these kind of things for you just by default. It will do it, but you have to force the thing into to be a string so that it connects the different strings together. Okay, otherwise if you're trying to do something like this, it'll tell you, I don't know how to add float in a string, right? That's the error message, okay? And that's what it means for it to be strongly typed. And that's the example here. If you have a 5 plus 3, in here you have the 5 in quotes and the 3 is no quotes, so these are two different data types, and it will not know how to do that. Okay, but if you went in there and you said, okay, int whatever the thing is in quotes, then we're going to force this thing to turn into an integer, and then it knows how to add two integers together. Okay? Any questions? Okay, so, and I have an example program in there for you. What you're going to have to do is copy the whole thing, including the comments. Everything in red is an explanation for the code, and then run it. You can change the name, the weight, the age, the grades, whatever. Change the actual values. You can even change the names of these variables. If your code breaks, I actually like that because you're going to learn more by encountering errors than if it was to just work perfect right off the bat. So if you run into errors, believe me, it's actually good for you. Okay? So that's one of the assignments that you're going to have to do is you're going to have to type this sample program. And I also have, let me go back. Yeah, I'm just going to go next. All right, there's a PowerPoint that goes with this. And let me just go over it. Now I can just go over it right in here. There you go. I'll do this here. Okay, so just like some basic terminology. Right, what's a computer? It's a machine, right, that can follow some instructions. The programs we write are the instructions. The hardware are all the physical components of the computer. It's the part of the computer you can kick. Okay, the software are all the programs we write. The firmware, there are special kinds of programs that are kind of permanently wired into the hardware. So if you have a Windows computer, the first dark message that shows up when you turn on the computer, that's the BIOS. That's programmed into the motherboard. You can't just easily change that thing. You can flash it, you can change it, but technically it's kind of wired into the hardware. Different kinds of hardware components, right? The input devices or output devices, right? Keyboard, mouse, output is something that shows, you know, a way to show information on the screen or out of the program. One way to do it is on a screen. You can also have output to a file. You can output to a paper. You can make noises, right? There's different ways for you to get information out of the program. This is the memory, right? Not to be confused with hard drive, right? The storage devices. This is your processor, right? That's the brain of the operation. Whenever you're doing things like addition and subtraction, how does the computer know how to do these things? This piece right here, that piece knows how to do it. It's built into it. Okay, later on when we start doing selection, comparing things to each other, it also knows how to compare things. Okay, right, so common input devices, keyboard, mouse, touchscreen, you can talk to the computer, right? There's different ways for you to enter information into it. Common output devices, monitor, speakers, printers. Okay, again, your memory, this is the memory, RAM, this is where the variables get stored while the program runs. Memory is volatile, which means that as soon as you power off your computer, everything that's in the memory gets wiped out. This is your processor. Processor has two components. One is the control unit, one is the arithmetic logic unit. The arithmetic logic unit is the one that I just told you. You can add, subtract, multiply, compare. And the control unit, all it does is it grabs information and sends it back and forward from RAM, to RAM, from RAM. Gets it from RAM, puts it in RAM. Okay? We're not going to have to concern ourselves with these like lower level things. But if you're taking an assembly language class or a computer architecture class, those are the kind of tedious things you have to do. Okay, the operating system is just a collection of programs that makes the hardware work. Okay, so if I wanted to, for example, print something here, right, I go File, Print, right? This example right here, this program, PowerPoint, is a software, right? What I'm going to do is as soon as I hit the print button, I'm going to involve the operating system. I'm on a Mac right now, so my operating system is OS X or whatever, right? And the operating system is going to call the driver. The driver is a little program that knows how to operate the printer, and then that little program prints the message. So the operating system is like the middleman in everything that happens on your computer. It makes the hardware and software works together. Okay? All right. Source, the source program, that's the code you're going to write. Object program, you're not going to see that in Python, but there's an object program that is in the back also. So you basically translate your source code into an object code, and then that gets understood by the computer eventually. Okay? There's high-level languages like C++, Java, Python. There's mid-level languages. They call it mid-level languages because they kind of incorporate both of some parts of both languages, high and low-level languages. And there's the assembly level language, which is the lowest level programming language we write in. Okay? Fortunately for you, we don't have to deal with this. Okay? And then the final thing that you do is you translate your assembly language into machine code. And what is the machine code? It's just a bunch of ones and zeros. And the ones are on, the zeros are off. The computer, there's either electricity flowing through through the little circuitry, and it's on, or it doesn't, and it's off. And we choose to represent that as ones and zeros. Okay, bugs are anything that's wrong with your program. Debugging means fixing them. Compiler, let's just say that this is your compiler, right? So when you run this code, right, you're going to translate this into a machine language, and that's the purpose of the compiler, to translate your code into something that the machine can understand. And I'll show you a little bit more of that. Okay? There's also interpreted languages and compiled languages. So compiled languages, I'll show you an example of that in a second, but C, C++ are examples of compiled languages. Python and Java are examples of interpreted languages. Okay? Compile time error, or these errors that we saw so far when I introduced the space and it gave me a syntax error, that's a compile time error. Okay? And I'll skip that. Oh, algorithm. Well, I'll tell you what an algorithm is. First of all, what's an algorithm?
It's a set of steps that hooks it up.
Thanks, Jerry. So it's a set of steps that you need to follow in order to solve a problem. That's an algorithm. Okay? It's a fancy name for a recipe, right? You can have an algorithm to boil an egg. You know, heat up some water, put the egg in it, wait a couple minutes, turn off. Right? That's an algorithm. Okay? Okay, so the next thing that I have in here is more about these high-level languages. It's kind of more of the same. All right, and it jumps straight to this page. Hopefully it loads. On the thing on the left is a program written in assembly. The thing on the right is a program written in Python. Right? You can see that the lower level language, assembly, is a lot more difficult to write, a lot more time consuming. It's harder to figure out if something goes wrong with it. But it's a lot faster than the higher level languages. Okay? So that's its benefit. The disadvantage is if you write a program in a lower level language like assembly, it will only work on a specific type of a computer. So if you wrote it on Intel, it will work on only on a certain type of an Intel processor. If you wrote it on an AMD processor, it will work only there. You can't really run an assembly program in different operating systems. So I can't write one on a Mac and run it on Windows, right? So that's the disadvantage of low-level programming languages. Okay. By the way, if you open up any of these executable files, so that's basically the machine language, right? So when you compile a program from a compiled language, which Python is not one of those, and it will finally, at the end, it will generate a exe file. If you double-click the exe file, it just runs. It does not require any special anything for it to run. Okay? If you try to open up with a text editor, it will look like this, right? Just a bunch of nonsense. So you can't really figure this stuff out. The best thing you can do is you can use a disassembler to convert this thing into assembly language, and then from there you can figure out some things about the code. Okay? All right, so I already told you what's a high-level language. It's much easier to program, right? They can run on different computers. They're more portable. Now, what's the difference between interpreted and compiled language? Okay, so first of all, a compiled language, there's a picture in there, right? So you have, let's say, for example, your C++ program, right? Your C++ program is just like your Python code, print, do something, right? Then, when you hit the compile button, the compiler gets involved and you create something called object code. And then, your object code gets linked with other object code which already exists into the language by a linker into a final executable file, which is like, say, the Windows calculator. You just click it, runs. Okay? That's an example of a compile type language. The interpreted language does not go all the way to an exe, right? So let's say if this is your Python program, you would compile it, you would create some kind of an object code for it, but that's where it ends. There's no linker that creates an executable file. Instead of a linker, what we have is we have a virtual machine, like Java Virtual Machine, for example. Okay? But that means that you have to have a special program installed on the computer before you can run a Java program. Same as you're going to need Python installed in order for you to run Python programs. Okay? If I wrote a Python program and I don't have a Python installed, not going to work. Okay? So what is the advantage of a compiled language like C? Once you have your machine language, the final executable file, you don't need anything special. You can just double click it, runs, and it's much faster. Okay? If you have an interpreted language, obviously you're going to need to have the virtual machine or interpreter to run the program. Another difference is the interpreter reads the object code line by line and executes it line by line. So it's a little slower. Okay? The advantage of an interpreted language is that you can put that virtual machine on whatever you want. If your toaster supports it, you can put Java on it and program things on it, right? That's why smartphones have Java, okay? Or Android has Java. Okay, so, and you know what programs are already, right? Commands or common parts of a program. Input, output, processing, there's some conditions, repetitions, there's functions. Okay, I already told you what bugs are, syntax errors, right? Just errors that result because you broke the language rules. Okay, there's also runtime errors. So your program runs, but it's not doing what it's supposed to, or it runs and then at some point it crashes. Right, that will be an example of those. Right, and that's about it for these. So next thing that I want to show you is, so I already told you output variables, data types, what are the different kinds of comments, right? The different basic terminology. And what I'm going to do now is I'm also going to cover what I'm going to cover on Thursday. So I'm going to give you what an input is. That way, next time we come, you can just work on the assignments, okay? Okay, so what is an input? Let me go and get to this. Okay, so you had output, right? Output is done using print, right? Output is information that comes out of the program, okay? We also have information that can go into the program, okay? So input is information that goes into the program, okay? So let's say I have, I don't know, new name, right, is equal to input, and I'm going to say please enter a new name. Okay, hope I fixed my stuff up there. Yeah, I did. Okay, so what am I going to do? Let me just run the program, and actually I'm going to do something else. Under this, I'm going to say print you entered, and I'm going to say a new name. Okay? So from what you have seen so far, whenever I run the program, it just shows everything, right? But now when I run the program, it is not going to show this. It will actually stop at this line, right? Our code gets executed line by line, top to bottom. So the first thing it's going to encounter is this piece of code, which is going to ask me to enter something, and only after I have entered something is this going to show. So if I run it, right, it just freezes right in there, okay? That is this line right here. So this here, this is called a prompt, right? So let me just label it, right? That is your prompt, right? Or tell the user what to enter, okay? It is important for you to have a good prompt, like for example, like please enter a name. There you go, a name. Okay? It's important for you to have a good prompt because what if I didn't? Let me just erase this thing. And I'm just going to change it to like this. Right? I'm going to run the program again. and it just shows me this. But that doesn't tell you anything. What am I supposed to do? Am I supposed to enter something? Is the program thinking about something? I don't know. Okay, and that's why you want to tell the user what to do with the prompt. So I'm going to tell them, please enter a new name, right? So they know what to enter. Okay, so this input is another reserved word, and similar to print, tells the computer to do something specific. What is it telling it to do? Well, it's going to get some information. As soon as the user hits the enter key right here, that information is going to get stored into my variable new name, and I'm going to show you that thing. Okay, so if I run it again, all right, please enter a new name, Alex, right? And that's the string. Okay, so that is the default input in Python. So this one is input of a string. Okay, let's say I had a different one. So I wanted to do age is equal to int input. Input, please enter a new age. Okay, it's the same thing as before, except I'm putting an int in front of it. Okay, so that's your example of input of a integer. This, I'm going to copy this, and I'm going to change this to age. Right, so if I run it, I'm going to enter some garbage here, and then I'm going to give you an age, right, and that's it. Okay, now let me go back to the program, run it again. I'm going to run it again, oops, and I'm actually just going to take this out for a second, just disable this piece of code, right, so that I can show you that the kind of things that you can enter into a string. So please enter a new name. Obviously I can enter whatever I want. As far as characters are concerned, I can enter an integer, right? I can also enter a float, 3.14, right? So the input when you have a string can be anything, right? Input of a string can be string, can be int, can be float, right? So I can enter whatever I want as long as the input is just input, okay? But when I have this here, right, let me just turn off this piece of code now, so I don't want to enter again. Okay, so now I'm going to ask the user to enter an age. You already saw that this thing works if I have just an integer, right? No problem, okay? But now what I'm going to do is I'm going to run the program, and I'm going to give it a string. Nope. Invalid literal for int with base blah blah blah. So it basically tells you I'm expecting an integer and you give me this garbage, okay, which is a string. Okay, now let's go back again, run the program one more time, and this time I'm going to give it a 3.14, which is a float. That's also not working because same kind of a deal. The expected input is supposed to be an int and you're giving it a float. Okay, so the input of an integer can be integer only. Can't have a string, can't have a float as an input. Okay, and that's one way, that's one thing. And then there's also an input of a float. Okay, so let's go with weight is equal to float input, and by the way you can put extra spaces in there, it's, you know, doesn't really matter. Input, please enter a new float or new weight. All right, and by the way, it's a good idea in your prompts, which are these messages here, to tell the user what the data type is supposed to be, right? Whole number, right? Okay, and then here I'm telling them please enter a new weight. I want to have decimal. Okay, and I'm going to show you this thing again. All right, you entered weight. All right, I'm going to turn these two lines off. I'll turn them on later when I'm done with the lecture. Okay, so when I run this, I'm going to run it again. All right, now it's please enter a new weight. Okay, in decimal, I'm going to give it a decimal first to see if it works. It should, and it does. Okay, then I'm going to run the program again. And this time, instead of a decimal, I'm going to give it an integer. That also works. Okay, and now the final one is I'm going to run it one more time, and I'm going to give it a string. All right, run it. Nope, could not convert string to float. It actually tells you exactly what the issue is, right? You enter the string, can't convert it to a float. Okay, so the moral of the story is input of a float can be int, integer, or decimal, right? No strings. And that's about it. Okay, any questions? So far so good? I'm almost done. So I'm going to show you one more thing. Let's say, for example, that you had a value of weight, right? Weight is equal to 1, 2, 3, 4, 5, 6, right? Okay, let's just give it like that. 1, 2, 3.45. Okay, and I want to show, or let's just do this. Yeah, weight. So I'm going to show here. So I'm going to do it like that. I'm going to say old value of weight is this, enter new. Okay, just like that. All right, so the reason I'm doing this is because that was the format that we used for the print. Remember, you have some text, then you have a comma, then you have some variable, right? You can do that. Right, that was the first one I showed you. And I'm going to try to do this for input. I run it, and nope, doesn't like that. What does it tell me? It tells me input expected at most 1 argument got 3. So when we get to functions, you're going to know what an argument is, but to keep it simple, it's basically telling you I'm expecting for this one thing to be one thing, and you're giving me one thing, and then another thing, and then a third thing. All right, those are the 3 arguments. So how am I going to convert this thing to a single argument? Huh?
Print it first.
You could do the printing first, but if I wanted to do it straight here in the input, I'm going to do that in here. Like the easiest way would be just str, right? Remember the string concatenation? When I do this, now what I'm doing is I'm converting these 3 strings into one big string. So now I hopefully would fool it into thinking that it's a 1 argument. And if I run it, right, the old value of weight is this, enter another one. Okay, so maybe you want to put some spaces in there. Remember, the commas automatically insert space. Whoops. All right, you can do that. All right. And then it will look better. Okay, so that's one way to do this. And another way to do this, so that's one way. Just shorten it. Okay, so this is the first way. And the other way that I can do this is, I'm going to paste this here. So this is okay. All right. And then the first one that I had, let me just put it in there just to tell you that this one was the bad one. So if I had this as comma, 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 all right, this one here is bad. Okay, and now this one here is going to use the percents. So what I'm going to do is I'm going to take this whole thing out. I'm going to combine these 2 strings together into one. I'm going to just say old is percent, I don't know, 0.2f. And at the end, I'm going to say percent weight, right? And if I run this, there you go. Now it works. Okay? So that is how you do input in Python. Any questions? Yep.
Why didn't it escape your comments when you added the hashtags again? where it says bad and okay? How would you escape your comment?
What do you mean? How does it escape what?
So you have the hashtag wait,
Mm-hmm.
right?
Yeah.
And then when you enter the hashtag again,
Because you're thinking of multi-line comments. Multi-line comments have a start and an end.
so it's just the comment's only good for the line.
Yep, exactly. So I can go in there and I can do, that's okay, right? So yeah. So as long as you're starting in line with a pound, there could be other pounds anywhere in that line, and it's not gonna turn off the comments.
Is there a way to escape it?
No.
No.
Yeah. If you're looking for a way for you to start and end the comment, you could do things like, do the single three quotes and then end it at some point, like that kind of stuff. But don't do that. Yeah, you'll just run into problems. Okay. Any other questions? We're good? Sure? All right, I'll take your word for it. So what I'm going to do is I am going to post these notes and the video that I'm making right now on the class webpage. Probably put it right under there. I have also put some old lectures from other semesters. I'm actually teaching this class at MPC right now, so they're a little bit ahead of you. I posted some of their notes. So if you want to look at that, look at these previous lectures. I will add today's lecture and a video that goes with it. Takes a little while to process the video, so probably tonight some point. Okay, so what do you have to do for this week? Now that I covered everything, you got to cover these 6 assignments. 1, 2, 3, 4, 5, 6. They're not that hard. Let's just have a look at the first one. We're going to look at the first ones for today, right? The first one is just type up this example, including all the comments, everything in red. If I don't see all the stuff in red, I'm going to be taking points off. Okay, the reason for this is I want you to document your code, at least in the beginning, so that you know how things are working, right? What is the print? What is a variable, right? What is a string? What is a number, right? What is a list? I haven't covered lists in there, but I haven't told you about lists yet, but they're in there, okay? So we'll cover those in a lot more depth later, but basically a list is anything in square brackets, and then things on the list are separated by commas. So that's the first thing you have to type up. Type this whole thing up, get it to work, and then include however the program ran at the bottom of your code using multi-line comments. Okay, that's the first one. Then the second one is you're going to print out this message right here, capital CS, right? CS, right? This is what you have to show in the command line. How are you going to do this? Well, the easiest thing to do is just copy this whole thing here. All right, go to your code. Here's your P2 hint. All right, so this is your P2 hint. All right, so you could just paste all this stuff in there. All right, and then you're gonna go and put print, right, and then close the quotes. Put that in there, and that will be for every line. So print, quote, right? Print in there too. Okay. And you do that, oops, I move things around, move that, like that, okay? And I'll let you do the rest, okay? You do this for every single line, so do the rest of the lines. Okay, so that's your P2 hint. The other ones, guys? Okay, the next one. And that's for Thursday, you're going to have an example of input, right? Just like I did one with the output, right? There's your example of an input. You have a bunch of comments in there so that you can look back at your programs and, know how things are working. I don't require you to memorize things and remember things, but you should have all your programs handy so that you can look at how you're supposed to do things and use your programs as examples. And if you have lots of comments in your programs, you will know how to do things. If you don't have comments, you're going to be looking at your programs, you're going to be like, what did I do? Why did I do it? How is this even working? That's why I'm requiring you to type all the stuff in red. Okay, so that's the first one with the input. Then you have another one in there, which is wrong example. Hold on. I'll show you. Okay, so for this one, what you're supposed to do is you're supposed to create this letter, right, the big C letter, using whatever input the user enters. So for example, let me just go in there. All right, so this is your, what's this? P4. Okay, so this is your P4 hint. Okay, I'm going to paste this whole thing in there. All right, and this time, if I ran my program with what I had as before, if I did this, let me just delete this one. Yeah, wait. Get this here. I'll just show you for a couple of lines and then you'll do the rest. So same deal as before, right? If I ran this like that, let me just do a few so that it looks right. All right, leave it at there. So if I ran the program like this, hopefully it works. All right, whatever. Okay, so it will show the letter C made up of X's. Okay, but I don't want X's. I want the letter C, this piece, to be made up of whatever number the user, letter the user entered. Okay, so what I'm going to do is I'm going to tell them enter, I'll call it L, capital L. So input, enter a letter, all right, and then in here, percent, we're going to use it as S for a string. So they're going to be L, L, L. These are three things that I'm putting, and I'm going to replace these here with a percent %S, that's the string. Percent %S, that's another string, percent %S, right? On the next line, I have two of them, so I have to replace this with percent %S, right? Percent %S, and I'll leave these other ones, well, let's just do one in the bottom. Percent %S, make sure that you have as many variables here, so I have two S's, okay? Here I have one S, right? I can just do it like that, and if I run my program, alright, that was the first one. I'm going to enter another one in there. Now the C is made up of ones. Okay, so that's what you have to do for all, for the rest of the lines. Okay, do the rest of the lines. Okay, so that's that. Any questions? Good. Okay, the next one is, let's see, save this thing. Okay, the next one is an example or an assignment which asks you to do the following. Okay, you're going to write a program which computes and shows the sum and product of two numbers. The typical algorithm, just like most programs, is you're going to have some kind of an input. The information is going to be entered by the user. You have to store it somewhere. Where is it going to be stored? Make two variables, num1 and num2. Okay, and then you're going to have your processing or your math, where these are the actual formulas, right? Sum is equal to these two added. Product is equal to these two multiplied. The processor knows how to do addition and subtraction, multiplication, and then you have to show the output. Okay. So let me give you an example of this. So this is your P5. All right, so this is your P5 hint. All right, so I'm going to do division. So let's say we have A is equal to int input. Please enter num1. All right, and keep in mind that I'm asking you to create different variables. In your case, I'm calling them num1 and num2. Okay, but I'm using A and B. Okay, so, and then in here I can show you is equal to A divided by B, and I can show you print A is the variable, divided by B is equal to div. Okay, So if I run this, alright, so this is 4, 2, right? 4 divided by 2 is 2.0, okay? So that's that. The next one that I have is P6, or what are these numbers?
Do you
P5.
have to do any error handling, say they enter, not an engineer?
Not for now. Not for now. I'll show you how to do the error handling when we get to loops. When we do the while loop, then I'll show you how to prevent these error messages from showing. Okay. So 5. Oh, and the last one is the multiplication table. I gotta fix the numbers. Okay. So the multiplication table goes like this. You have a bunch of numbers. All right. These are the numbers. I'll show you how it goes. So this is your P6 hint. Okay. So the P6 goes like this. You're supposed to show this. All right. And this one here, print that. Okay. And I'll leave these, well, I'll do one more. Print this, right? So that's the thing that it's supposed to show. Okay. And how we're supposed to do this. So this number right here is equal to this times this. This number right here is equal to this times this. Right? This number here is equal to this times this. Okay, so all I got to do is I'm going to replace this here to %.2f, and same with these here. So this is that. This one here is that too. And what are the values that are going to go in there? They're going to be 0.1 times 0.1. That's the first one. The second one is 0.1 times 0.2. The third one is 0.1 times 0.3. Right? So when I run this, it should show me the same numbers as before. There might be a little off, and if moved a little bit to the left and right. All right, yeah, it'll actually look right. So that's what you have to do for this line too. So do it for this line and this line. Okay, so all you got to do is replace this here with %.2f's and then insert the correct formulas so that you can get what the assignment is showing you. Okay, and that's everything for this week. All right, any questions? Yes?
How do you submit this information to you?
How do you submit this information to me? Okay, so let me go and switch the...
And can we do it multiple times?
Yes, you can resubmit multiple times. Yeah. And when you go to the assignment, there's going to be a button in there. Let me switch the student view. I don't know where the student view is. Student view is all the way at the bottom. Okay, so let's say I'm going to go in there week 1. I want to submit here, P1. Right? There's a button right here, submit assignment. Just click this. Then you go choose your file. A million clicks because this is Canvas. And then open and submit the assignment. Okay, and Moodle, which was the old system, you can just drag and drop into it, but that's, I guess, too advanced for these guys. They're just interested in making money. Okay? By the way, if you want to buy stock, you just Google Canvas, right? It's a for-profit system, and the community colleges got duped into buying this garbage. And I'm the only one protesting about it, but what do I know? I'm just the computer science instructor who teaches most of the classes online. Okay, so anyway, that's how you submit assignments, and it should show in there, and yeah, you can submit another one. You can go resubmit assignment. In Moodle, it will let you delete the old file. In here, it's just going to create a stack of files, which makes my life more difficult. But as far as you're concerned, just upload another file. Okay? Questions? So you are welcome to resubmit assignments. So what's going to happen is, at the end of the week, I'm going to go in there, I'm going to grade the assignments. If you forgot to include the comments at the bottom of your code to show me how the program ran, right? So I'm like, what would I include? I would be including all this stuff in there. All right, I'm gonna put that in my code, all right, where this stuff is, right? That's how my program ran. I'm gonna save it, I'm gonna submit it. If this piece is missing, I'm gonna take off like 30% from the program.
You
If-
took off like
if-
80% of my points.
If this piece is missing, I'm gonna take off another 30%, okay? So the idea is, I'm gonna be very brutal with the grading, but the good news is, you're welcome to resubmit the assignment. One time per assignment, okay? So if you don't wanna be losing up to 60% off of each of the assignments, make sure it has these comments on top, and then show me at the bottom of your code how the program ran. Okay, if you got these two, you're good. If they're missing, I'm gonna be taking points off. If you see like my feedback on the assignment says something like it's untested, that means you didn't test the program, you didn't run it for me. Okay, same thing if your program has some kind of an error or something's wrong with it, make sure you run the program, make sure you put the error message on the bottom, and then send it to me. Because I don't wanna download your program, run your program, look at the error message. I wanna just look at the error message. It shows me that you tried it first too, right? And don't try to describe in words, oh, it's giving me this error message, and you try to interpret the error message for me. Just paste the error message in your code, send it to me, or just send me the error message and the code. Either way, you're gonna have to send both. All right, so regrading is okay, one time per assignment. If you lose points, you're welcome to fix it and resubmit it. I'll regrade it for you for full credit. As far as turning things in a little late or whatever, I am not really, I don't really care. As long as you turn it in by the end of the semester, I'll grade it. I'll give you full credit. That being said, this is like an online hybrid class, so make sure that you turn in things on time so that you don't get dropped. If you haven't turned in anything from week 1, I might drop you at week 2, right? Because obviously this is not a class maybe you can handle. Okay, I hope that's not the case. So, any questions?
On
Yep.
the catalog, it says there's an online component. Is this what this is?
Yeah, there's 2 class sections. There's an online class and there's the face-to-face class. The online students are welcome to come to this one if they need help. You are welcome to do this online and not come to class.